Hi friends, today I have taken a new questions related to the restriction digestion, restriction mapping, and this is the experimental basis of the questions. Before this lectures, I have solved questions with the restriction digestion, but this is something different from that question. That is also deep questions. Before this lecture, I have solved the questions. This is the deep questions in comparison to them. If you have no see before this lecture of the restriction digestion related questions, then please go back again to the restriction digestion questions mapping and then come back to these questions. This is different questions and also deep questions. I think if you can understand these questions, then most of the questions related to the restriction digestion you can solve. So do not hesitate about these questions. This is big questions. This can irritate you, but this is a best question to understand on the basis of experiment. Okay, so first point out that what the question is saying. Okay, this is gel, and this is plasmid, this is DNA fragment. Okay, the question says you are attempting to clone a linear DNA fragments. This is the linear DNA fragments. Also, with the same questions before this lectures I have described. Okay, so this is the linear fragment you want to clone in the plasmid, shown at the right into a circular plasmid. The site at which a number of restriction enzyme will cut are indicated. Okay, I have described BAMH first, TQR first. Along with the size of DNA between the sites, for this experiment, you linearize the plasmid with BAMH first. BAMH first linearizes. We linearize the BAMH first of this plasmid, and this will be transformed into the plasmid. Okay. Mix with the linear fragment which also has BAMH first cut sites at the ends. At the ends, these linear fragments have BAMH first sites. Okay. Then ligase will perform to ligations. I have described these topics before this lecture. So please, if you not have listened or not have seen the lecture, then go back to the back lectures. Then BAMH first cut sites at the ends, add DNA ligase and transforms bacteria. Okay. Bacteria, you mini-prep the plasmid DNA from 3 colonies. Points out that the questions differ in 3 colonies. Okay, I have taken only 1 colonies on that questions, but there is 3 colonies. That can confuse you. Okay, so mini-prep. There is 3 colonies. Transformation done with 3 colonies. And all these 3 colonies is developed on the plates after transformations. Okay, all these 3 colonies, many bacterial colonies in the plates. Okay, colonies first C1, C2 and C3. Blue-white selections was not available for this experiment. Also it says, so you need to perform restriction digestion analysis which bacterial colonies contain desired recombinant DNA. Point out, this is different questions. Restriction digestion analysis should be performed. So, which bacterial colonies contain desired recombinant DNA, the original plasmid vector plus linear DNA insert. The question say there is 3 colonies C1, C2, C3 and the transformation was transformed with the 3 colonies, and there is another colonies C1 and that is C2, C3. Each colony's plasmid becomes isolated. Each plasmid after transformation, point out, after transformations of this fragment into the plasmid, into the circular plasmid, these bacteria will be plated on the plate, and if growth would be occur of these 3 colonies, then each colony's plasmid DNA would be isolated, okay, in different way. That is C1 plasmid, that is C2 plasmid, and that is C3 plasmid in separate tubes, C1, C2 and C3. Okay. Then the original plasmid vector plus the linear DNA insert. So this is the diagram. Okay. Panel A is a representation of an agar gel containing plasmid DNA. Panel A is a representation of an agar gel containing plasmid DNA. This is panel A. Okay. This is panel A. This is panel B. So panel A is a representation of an agar gel containing plasmid DNA that has been incubated with the indicated enzymes. Incubated with the indicated enzymes BAMS first, EcoR1 first. Okay. So the question say, after isolation of the plasmid, okay, after isolation of the plasmid, the restriction digestion experiment analysis was performed, and the digestions which was obtained by the different C1, C2, C3 colonies was run on the gel. That is a marker. That is marker 5 kb, 4 kb, 3 kb, 2 kb, 1 kb and 0.5 kb. This is the marker, panel A. This is marker, and there is the 3 colonies of the plasmid that was digested with BAMS first. When the digestion was performed by BAMS first, the gel fragments, after gel analysis, this fragment was obtained with C1, C2, C3. And after EcoR first digestion, the different 3 colonies contain that fragments. Different 3 fragments. So by analyzing this experiment, on the gel, you should need to fill up the gel bands on the B lane, that was digested with BAMS first in third. With the help of this gel, after analysis of these gels, you should need to fill up the DNA fragment at DNA size with Kb in C1, C2, C3 and the B gel if digestion would be performed with BAMS first and in third. This is the questions. So you should need to fill up this. So before this lectures, I have mapped the restriction digestion. I have mapped, that was orientation based, first orientation, and another was second orientation. Okay, another was second orientation, this was first orientation. So if in the first orientations, point out without first lecture you cannot get easily to solve this. Okay, so please go to the back lectures if you are not see the back lecture. So there was, if digestion would occur and the ligation of the 2 kb, this was the 2 kb. Okay, the total length was 2 kb. So if the digestion was, if the ligation was occur in first orientation, that's look like this. Okay, so the directions of these DNA fragments would be look like this: 1.25 kb, 0.25, 0.5 kb, and that was the BAMS first restriction digestion cut sites, and that was BAMS first restriction digestion cut sites. The length was 1.25 kb, 0.25 kb and 0.5 kb. So this was in third, this was EcoR first. Okay, and that was after, if there was ligation is completed of the foreign DNA, so in the first orientation then there was echo R first, and there was 0.75 kb of the total length with BMH first and echo R first. That is BMH first, echo R first, 0.75 kb in the first orientation. Point out again. And if there is second orientations attachments will be performed, then the echo R would be here 0.75 kb. Okay, 0.75 kb. The orientation would be changed because this may be the probability to attachment that the DNA fragments would be attached in which orientation. That may be attached to the same as like this, or that may be orient or inverse and attached to the plasmids. So if inverse attachments occur, then the direction would be the change. Then because 1.25 directions in the clockwise you can say, and if there is attachment in the anti-clockwise, then the 1.25 direction would be here. So for simple diagrams, I have draw this like this. Okay, I have draw like this. Orientation would be changed. You can also complete according to your orientations. Okay, so there was echo R first here in second orientation, and if there is attachment or ligation with first orientation, the echo R one side would be the here. So this may be the confusions. Then after restriction mapping, you can analyze that which colonies have performed the successful transformation, which colonies. So point out BMH digestions. Point out that the results of BMH digestions in the first orientation, if you digest with BMH first, there is BMH first sites and there is BMH first sites. The total length will be 2 kb. So it will obtain 2 kb DNA fragments, and the remaining is here 3 kb. The remaining, that is 0.75, point out, and 2.25 kb from here to here. Okay. So BMH digest here, 2 kb plus there is 3 kb, because 3 kb in the first orientation, and the second orientation result would be the same, because BMH first is the two sides, there is here and here is here. So that is also 2 kb plus 3 kb fragments. Okay, in case of BMH first digestion, point out, in case of BMH first digestion, in both orientation 2 kb, 3 kb, 2 kb, 3 kb. Then if you digest echo R1, what would be the results? Echo R1. There is in the first orientation echo R1, and that is echo R1 sides. So the length 0.5 kb and 0.75 kb, 0.5 kb, 0.75 kb. If you add, then the length would be what? 0.5 kb, 0.75 kb is equal to 1.25 kb. Okay, 1.25 kb. Okay, and the remaining length would be here. The remaining length would be here. So 1.25 equal to 1.50, and the remaining is what? 2.25. 1.50, 2.250, if you add, then the result would be 3.75. Okay, 3.75 kb in the first orientation. If you cut with the echo R first, and with the second orientations, there is echo R first here and there is echo R first here. So that is look like here. 0.25, 1.25, 0.75. So 0.25, 1.25, 1.50 plus 0.75 equal to 0.75 plus 0.25 plus 1.25. If you add, then you will get 150, 2.25. Okay, 2.25 plus the remaining would be here. Remaining would be here 2.75. Okay. So this was the two orientation result of digestion with EcoR first, and this is the two orientation result of BAMS first, 2 kb, 3 kb. So after mapping, analyze this gel, that what is the result of gel. You will see here that C1 fragment is 3 kb, 2 kb. So the digestion with BAMS first is 3 kb, 2 kb in both orientations. That so the C1 has successfully transformed the foreign DNA. Has successfully transformed the foreign DNA. So the bands obtained will be 3 kb and 2 kb, 3 kb and 2 kb. So C1 proof that it's carry the foreign DNA. It's carry the foreign DNA within this plasmid, because the after digestions 3 kb, 2 kb, 3 kb and 2 kb confirms. C2 carry only single fragments. C2 carry only single fragments. There is no another fragments. So why? Because if 3 kb there is not transformation occurs, points out the total plasmid length is 3 kb. There is not transformation would occur, then only 3 kb band will obtain. So there is 3 kb. It's proof that C2 does not carry the foreign DNA. Transformation is unsuccessful in the C2. Okay, unsuccessful in the C2. And C3 also, so 3 kb, 2 kb. So it's proof that the bands prove that the transformation is successful in the C3 colonies, bacterial colonies. Again, the gel is showing that C1, C2, C3. Okay, C1, C2, C3. This so what kb? Near about 4 kb. Yeah, that's you can say there is 3.75 kb. That is near about 3.75 kb. And another fragments of C2, C1 is what? 1.25 kb. That is 1 kb and above 1.25 kb. 1.25 kb. So it's proof that C1 has taken successful experiment. Okay. And another, that is C2 only obtains 3 kb band. So there is not transformation. There is not transformation in the C2. Again, proof is successful. In the C3 colony, the band is different with the C1 colonies. Why? The band is differ with C1 colonies. Why? Because the orientation dependent. In the second orientation, 2.25 plus 2.75, both bands will be obtained if there is second orientation transformation takes place. So there is near about 2.25, 2.25, you will see here that 2.25 and 2.75, 2.75 bands will obtained. Okay. So there is the two colonies C3, C1. C3, C1, that's have successful transformation. Then the question is, if we digest BAMS first, Hin third. Okay. If we digest BAMS first and Hin third, then what would be the results of DNA bands? That's maybe the ask a big questions on the basis of experiment. This questions was sent by the US student and then I have solved these questions, then I displayed or solve this question for you. Okay. So C1, C2 and C3. This BAM as first, hint, third digestions, you should need complete what the bands would be obtained. There is, you should need to perform. What would be the bands? There is two BAM as first digestions. BAM as first digestion 2 kb plus 3 kb plus 3 kb. Okay, that is 2 kb plus 3 kb. And there is another first orientation, and that if first orientation, second orientation also 2 kb plus 3 kb if only BAM as digestions will take place. And if in case of 2 kb plus 3 kb, both restriction endonuclease act, both restriction endonuclease will act, that is BAM as first, hint third. So BAM H and hint third, there is echo R1 should be erased, only remaining what? BAM as first and hint third. There is asking BAM as first and hint third. So in the first orientations, I am taking examples only for first orientations. BAM as first, hint third. So hint third will act and BAM H will act both. Then the length would be 1.25 kb. Hint third, point out. I am denoting it. Hint third. Okay. So there is two. Both act, then the fragment will be 1.25 kb. Okay. And BAM, there is also here BAM as first. BAM as first. So the fragment will be 0.25 kb, 0.5 kb equal to 0.75 kb. Okay. 0.75 kb. That is here 0.75 kb. BAM as first is here, point out. And hint third, both will act. So BAM as first is here, that is one fragment. Okay, and that is one fragment. And the remaining fragment is here. What? 3 kb. Okay, that is 3 kb. This is 3 sites will be obtained. Okay, and there is probability. There is a lot of plasmids. There is a lot of plasmid because the colonies contain many bacterial cells. So the many plasmids. In many plasmids, most of the restriction endonuclease will act on both sides. That is here and here, here and here. So the fragments will obtain as like 3 kb, 0.75 kb and 1.25 kb. In some cases, only in the first orientation, only BAM as first will cut. Only BAM as first will cut. Probability that many, there is a lot of DNA plasmid or plasmids, transformed plasmids. Suppose that 1 lakhs plasmid. So 50,000 plasmids, the restriction endonuclease cuts on both sides. But in 50,000 plasmids, or you can say 25,000 plasmid, only hint third act or only BAM as first act. In that conditions, so the band also will be obtained 2 kb plus 3 kb. Okay, 2 kb plus 3 kb. Chance all this band will be obtained 1.25 kb, 0.75 kb, 3 kb plus 2 kb plus 3 kb, and also another is 5 kb. Why? Because if only hint third is act, point out, BAM as first does not act, BAM as first does not act in some plasmids, point out. This is careful. So in that condition, 5 kb of the plasmid will be obtained. only one cut in third, there is another not cut off in third. So 5 kb of the plasmid will obtained. Okay, 5 kb of the plasmid will obtained in first orientation. So C1 with BAM as first 1.25 kb you can fill up. I am lefting it for you to fill up. Okay, 1.25 kb near about here and 0.75 kb near about here. Okay, near about here, and 3 kb here, 5 kb here, 2 kb here. Okay, and so this was the fragment of C1 by MS and hin third. And also in the C3 colony the transformation is completed, but there is not EQR1, including here there is not EQR1. So C3 will obtain the same size of the fragments, because hin third and band match first, same size of fragments. Okay, if it would be the mention of EQR1, then the size of the fragment will differ in the gel. So you can make a question, if we digest with BMH first in third, then what would be the result of this gel? Okay, what would be the results of this gel? So hope you can also, this was the first orientations. If you cut the second orientation, then what would be the results? The results should be the same. Okay, the results should be same.